I just want to quickly run through what was the objective of this Python masterclass. Is the primary reason for actually running this is to kind of allay everyone's fears about programming, and it's not such an elitist thing that whatever assumption you may have, it's actually quite easy, especially now when we have such high level languages and there's so much of documentation, so much of videos and websites teaching you how to program. Previously, maybe 20 years ago, there wasn't enough references and examples. You had to figure it out kind of yourself. But those days are over. Now there's a lot of documentation and a lot of help available. Okay, so the first part of the program is to decide, to define how the programming language actually works. And this is true for any programming language. It's not necessarily Python. So we started off by defining what are variables and then what are arrays, the different types of arrays and how you use it and all of that. What I like about Python more than anything else is that it's very it's quite extensive yet simple. It's very flexible yet very specific. So you don't have that sort of elasticity in other programming languages. So that's why Python has really taken a liking to many developers, right? Especially when you're handling a lot of data, trying to clean it, trying to massage it. It's got a lot of intelligent functions that's built in. And it also gives you the granularity to go down and make changes at a very low level. So it's good for an expert. It's also good for a beginner. It's good for a novice. So the language actually grows with you. So when you understand the language is there to help you, then you should already start to remember that it is actually designed around your learning habit. As you get more comfortable, it allows you to make those changes and options and stuff like that. Then we talk about logical operators. I think we cover mathematical operations, we cover binary operations and stuff like that, just to tell you that from a computer perspective, what we really wanted to do is to make a decision or to complete a process, all right, or tell us something. So in that process, we need some sort of logic, some sort of step-by-step process for it to complete. So all programming languages are like this, all right? And then we went to lesson number 3 that talked about looking at the number system as a whole. Don't look at numbers as a pocket or a species or something like that. It's all very related, and what you need to actually pick up on. I told my nephew this, right? The easiest, the best way to learn is look for patterns, to look for things that keep reoccurring, because that is what even like when I do my programming, right? I always start off with import pandas as PD. So that is a simple first line that you would write, and then after that loading the data into your so you can see that even your activity that becomes a pattern in terms of how you actually solve the problem. And there's only so many things that could go wrong, and once you are like kind of comfortable understanding that whatever happens can be managed, then your confidence level to take on more difficult projects will increase. All right. Nobody got there immediately. Everybody had to go there step by step. And then finally, just refreshing your memory for those who have done algebra before. Algebra is very, very powerful in the sense that it does a lot of operations, like a lot of things that happening today. For example, blurring of my background, or coloring a image with contrast, darkening the image, increasing the size. It's all done using algebra. So algebra has been there for I don't know, maybe 2000 years. And we use that to build temples, we use that to build bridges, we use that for a lot of things. So now taking algebra and bringing it into computing is like a no-brainer. And algebra is another tool that we use. For example, you want to filter a record, you want to reverse the order of the record, or you want to select a particular group of records and create a new set. So all of that is done using algebra. So this is available in pretty much any language. So the introduction to Python actually is an introduction to programming, basically. Now, in the second part is when we get into the Python specific. Python actually shines when you talk about handling data, when you talk about plotting, and how easily it is for you to create classes and functions and to implement object orientation. So all these things actually is made very, very simple. And the whole purpose of Python is actually to make it very modular. Modular means like, Lego boxes. You have one box and then you add another box and then another box, and then suddenly you have this tall building. So that's the whole idea of Python programming, right? So it is supposed to be modular. So whenever you've written some code, don't try to rewrite it again. Make use of it and make the new changes that you want as a new feature, and then add it on to the old code. So you keep growing as a developer. All right. Then statistics and probability is one of the most boring subjects I ever studied in mathematics. But then today I am bound by going back and revisiting it because it is so important when we want to actually make a decision, especially in machine learning and deep learning. We use statistics and probabilities a lot. First, to determine whether our data sets are giving us the good probability of the actual real world. And then we look at the probability of us actually making the correct predictions. So we use probability and statistics in both ways to determine whether our machine is actually predicting well. So that's why probability and statistics has become quite important. And I didn't realize until very late that even simple things like fraud detection in your email, like Google detects fraud detection of fraud email using probability and statistics, right? So probability and statistics has been around for a long time, and today we are actually making use of it in a much bigger way to help us make decisions and to see how well our decisions are being made, right? So with that, we've actually covered the kind of fundamental background that you need to get started with Python programming. Then we went on to do the fun stuff. Okay, I don't know whether it was fun for you because it is a bit involved. It is a bit what is that? It requires a little bit of programming background and stuff like that. But this is where like what Ms. Radha mentioned today, what does it all mean? What can I use this for? I mean, how is it going to help me? How can anybody make any decision? Now that these questions are actually answered in this part where you have the web interface, you have some sort of interface where a user can actually view the value that is being generated by the program. So that's what we talk about in this part here. And there are so many parts to this. There is the web interface, there's the APIs, there's the backend. So there's quite a few things that come into play here. All right. So I just selected like certain verticals that are popular, and then try to describe how it's done. But this one is, I would suggest, is just an introduction to say that, hey, this is available. But when you actually want something, let's say you have a business or you have a project and you want to make certain information available, that's when you should kind of research how these things actually work using Python or using any other language to make it available. I think that's more kind of relevant to to you, because right now you're probably wondering, why would I need this? Why would I need an API? Why would I need web scraping? Why would I need machine learning? What does a machine learn? I don't need a machine to learn. I can learn myself. So lots of things, a lot of questions will come into your mind. So, but these are all based on your need, your situation, your demand, or your interest, your feeling, your gut feeling. You may have a hypothesis, and then you want to make sure whether it's fact. So you can actually use Python in these forms to actually study, right? So that's why I selected certain key topics that most of my students actually ask for, right? For example, web API and web scraping to extract a lot of information on the internet, because internet is just, some parts of the internet is free information. For example, Wikipedia, for example, Google public data. There are a lot of data sets out there on the internet which is free. For example, the stock market, that's a free data set. So if you wanted to do any sort of research, you already have this data set now available because of Python. You can scrape the data set, you can massage it, you can make a copy of it in a form that you want to use it for your processing, and keep it for yourself. And then convert that into an API. An API means when I call it, it gives me the data that I want. If you want something, I can push it to you. So it's a matter of transferring information back and forth. That's what API is for, application programming interface. So once you understand what data is available and what Python can do, you can actually create a service out of it. And a lot of people have made money just by creating services. For example, I'm sure you heard of Google, right? Google has done nothing but take the information that's already available in the world and made it into a service. For example, Google Maps. The maps don't belong to them. They just took a photograph of the world, converted it into an image, and made us pay for getting that information back from them. So basically, there is a lot of money in this business. And what is happening now, from my understanding, the banks, the telcos are getting into this business as well. For example, there's a lot of fintech companies that is doing payment gateways and money transfers and bulk buying, bulk selling. All of them need some sort of transactional engine, and these transactional engines are hosted inside the bank. Now the banks are monetizing that data by selling it to the fintech to make a service out of it. So which is actually quite interesting. You can actually go to sandbox at maybank.com, and you can see that they have some information available. Let's say you wanted to get a quotation for your car. You can actually get a free quotation from Maybank Sandbox. So these are things that is becoming available from the financial industry. I also see the medical industry making their services more available. That means now when the tide is very low for patient registration or admission, they're actually making it available for you to come in and book an appointment. Something like booking.com, where a hospital is actually now available for you to book, and the rates change because they want to keep the traffic flowing. So things like that, things are becoming more dynamic, information is becoming more available, and all of them need little bits of extraction of data, manipulating the data, and then using some machine learning to kind of project, make a decision, what is going to be the traffic tomorrow based on the traffic today, or based on the traffic in November, stuff like that. So we start to do correlations and try to predict and try to give some heads up to the team. Animation keyboards, I didn't bother with that so much, because probably what it is actually, in Python, you have this tool that allows you to automatically click on things on the web page like as if it's some user doing the work, you know. So it's like robot, uh, you know, they call it RPA thing, where you can point it to a website, you'll go to the website and put in the data and then submit. So you can actually do that kind of thing, keyboard controls automatically. All right, so that's also pretty fun. I mean, I tried it once. It was a lot of fun. I can actually make it seem like somebody went to a website, filled up a form, and then submitted. Okay, so the last class where the power went out, we talked a little bit about WhatsApp messages. I was trying to make it very current, very relevant, but then I realized that there's no real WhatsApp message group that I actually wanted to analyze. But then I just turned it into understanding how to read a text and then to specify specifically if this is the date, if this is the name, if this is the message, how to break it up and read it and put it into a structured format that I can analyze later, right? So that was the exercise in WhatsApp messages, all right? Another cool thing that we're going to do today for a short while, hopefully we should be done by 11:45 or 12. All right. I'm not going to go into too much of detail in this because I think you know, if you are interested in being the next Elon Musk or something, then you know you can drop me an email. Then I can forward your email to him. But the bottom line is, I just want to show you how a computer can now understand its environment just by looking at an image. Okay. So that technology has grown quite extensive. They have object detection, they have face detection, they have face recognition, they have so you can actually determine if it's person A or person B or person C or something like that. So it's gone quite extensive in terms of recognition of understanding the environment. So that's why today you have self-driving cars, which is like a no-brainer. I'll just give you an idea of what I mean by a self-driving car. So this is the simplest form of a self-driving car. So what we have here is just imagine the car is actually looking through the windscreen and it's seeing this part of the road. Okay. So basically, this is what we have defined as the road. All right. Just to give you an idea of what the car will see, just 1 second. Let me bring up my other slides that I use for my training. So this is how the car actually figures out what is the road, what is the pavement, and what is the objects. You can see that it's detected it as a car and it's given it a color blue. So everything that it detects that it thinks it's a car is blue color. So what it has done is that it's tried to identify its environment just by looking through the windscreen, and it's now been trained to drive on the road. The road, you can see, has got its own unique pixel color. So this is how a computer looks through the videos frame by frame and tries to figure out what are the objects that's available, and it gives it a color. So this is all done mathematically. It's called deep learning using convolutional neural network. And the mechanism that is actually doing this is called semantic segmentation. That means it's trying to see what species of pixels against the entire image. So you can see it knows that this is a tree, this is blue color sky, and then the gray color buildings and everything. So it's actually done a very good job. But in an actual self-driving car, just the camera alone is not enough. We need radar, we need sensors, because somebody can stand in front with a picture of a cow and the camera will think it's a cow. So we cannot have that. So we need radar to ensure that there is actually an object, a physical object, and then we need sensors to detect temperature and all those things, because the temperature of the road will be different from the pavement and the different objects and stuff like that. So what is happening in a real self-driving car is that many things are happening at the same time to confirm the actual understanding of the environment. Same for us human beings, you know. And even if your eyes is telling you something, your nose will tell you something else, and then suddenly there's confusion in your mind, right? The same thing will happen to the machine. So it needs multiple forms of input, right? So once we have managed to use semantic segmentation and generate this image, all right, we can now begin to start driving the car on that pixel and making sure that it turns right and left, given there is that same pixel color. All right. So to give you an idea of what's happening, so basically this is the car, and it will detect whether there is a pixel. You can see the pixel colors are shifting. In order for the pixel colors, so the pixel colors actually tell me where to start and where to stop. All right. So it is actually looking each time it comes to a junction. I'll run it again. So each time it comes to a junction, it checks whether left, right, or whether they can turn left, right. So you can actually go backwards, forward, circle, and you know, it all depends on how much intelligence you actually build into the car. So I hope you understand very, very high level in terms of how a self-driving car is actually kind of done, right? Any questions so far? Okay, and since today is the last class, just want to let you know that there are other ways of running Python code. Okay, all this time I have chosen to use Colab because it requires very little setup. Okay, I have uploaded lesson 14. Okay, so you can keep a copy. But this one will have a problem running on Colab because it needs a window to display the actual car driving, right? So it's not possible to be run here. But you can use a free tool called Visual Studio Code. Okay, it's a free open source tool, and I have no gain or anything like that. It's something that I strongly recommend. You can download it to the different platforms that you're using. Okay, you can have a personal copy of your own. All right, and what is nice is that you can install a lot of extensions. Okay, so if you were to look at my projects, if I open my lessons, my project folder, which is under Python Miter class. And if I open my project, you see I can actually copy all my lesson as it is. Like for this example, right, lesson number 5. It's actually coming from, one second, this is, so if you went to your, you can actually go to file and then download file as either as a .ipy notebook file. This is actually a Jupyter file. This is a regular Python file. So you can choose to download it with either format, and you can save it in a particular folder, and then you can open it using Visual Studio Code. And Visual Studio Code has got an extension to include Jupyter notebook files. So you can see I have quite a bit of stuff installed. So I have the Jupyter notebook is basically what Colab is all about. Colab is just Jupyter notebook is actually a free software, and Google has taken that free software and made it available to you, calling it Colab. This is what all the big IT companies do. They take all the open source software and make you pay for it, because they have made it into a service. So remember the data handling class? So it is exactly like how we had it in Colab. You can hit the play button to play this content. Then you will see the output exactly the same as how it was on Colab. So you don't have to have like a internet connection all the time to run it. You can actually run it on your local machine. So I would strongly recommend for you to install Windows, the Windows version for those who are using Windows, and install some packages that will help you write Python code. So for example, I have quite a few. I have Pylons, Python IntelliSense, Python extension pack. This is the one that has got about 2 or 3 files in it. I highly recommend this because all Python programmers will be using this. This is also useful. This is the extension for Visual Code, and it helps me to complete my coding. That means I can write half a code and then it completes the line for me. So it's got some intelligence there. All right. So these are little things that will kind of help you, because I don't do all my work on Colab. I know that a lot of people may have issues with their PC being old and not enough memory and stuff like that. You still can use Colab, right? But for those who want to do work, let's say private data or data you don't want to share, then I would suggest use Visual Studio Code. All right. So be careful that there is another tool called Visual Studio. Okay, this is how Microsoft kind of sticks it up for you, because Visual Studio is a completely different product. Okay, so make sure you see the word code, CODE there, because Visual Studio, which doesn't have the word code, is not free, is paid. Okay, so don't for some reason think, and the logo is exactly the same, it's just that it doesn't have that last bit there. All right, so it's very dangerous and very misleading, this Microsoft. So don't, if you want to get this, you can, but you have to pay. And there's also a community version that is free, but it's not that great. All right, so you can actually, so they have a community version, they have a professional version, and they have an enterprise version. So the community version is free, professional is paid, that's for single users, and enterprise is for a large organization. All right. So be sure not to get mistaken with Visual Studio. I'm talking about Visual Studio Code. And by the way, both are by Microsoft. Visual Studio is very much tailored for Microsoft products like the .NET product, the C Sharps, and the MS SQL, and all the other tools that they have, F Sharp, C Sharp. I think sometimes it sounds like some music class. But basically, this is Microsoft's product, and it's for a fee. This one is for free, and it's quite powerful, and it's widely used. It's one of the most popular. We call this integrated development environment, IDE. So whenever you look for an IDE, there are many in the market. So for example, for me, I have IntelliJ, I have Android Studio. These are all very popular, but they're very specific to that particular operating system or tool. So it's not necessary for you, but Visual Studio can handle all of it. All right. So if you all don't have any questions, we will take a 15-minute break before we get we take some questions and some suggestions from you guys. Okay, let's the question in the chat. There's a question in the chat asking, just to confirm, is Visual Studio Code same as Colab in terms of purpose of programming? Okay, don't misunderstand me. I'm not trying to confuse you. I'm not trying to make it more complicated. But at the end of the day, I would like to give you options for you to choose for yourself what is the best tool to use. So I've created this file. I've shared it in the group, in the chat right below. Okay, for Python, not installation, but for Python development, what are the available options that you have? Okay, so the first option, no, it's not the best option, but it's got its benefits and weaknesses as well. But to me, it is the most flexible. Okay, it's got it's because you can do extensions with Python, with Visual Code extensions. That means you can install extensions for Python, you can install extensions for Angular, Ionic, Java, Kotlin, all the languages out there. It is highly flexible, highly recommended for, I would say, for flexible programming. Okay, that means you can develop in many different platforms. So I would suggest Visual Studio Code. Okay, and then you also have Google Colab. Google Colab is just purely a development environment. Okay, it's not an integrated development environment, meaning it doesn't have, it doesn't store the files on your machine. It's stored on a server somewhere, googleresearch.com. So you cannot say they are the same, because Google Colab is loosely based on Jupyter Notebook. Jupyter Notebook is actually a software. It's an open source software available by the Anaconda community. So just like Python has got a community, the other big snake, which is an Anaconda, it's also got a community. So they provide Jupyter Notebooks as a service. And Google has taken Jupyter Notebook as a service and made it into Colab. And Colab is actually designed for data scientists, primarily used by data scientists to do quick and dirty testing for their data, to see the results and to share those results with the community, because whatever you put up in Google Colab is actually read by Google. All right, or you can even share it with other people, giving them access and so on and so forth. So you cannot say that Google Colab is the same as Visual Studio Code. Then it goes down. Now I'm giving you options not to confuse you, but for you to really think about what sort of Python programmer you want to become. Now, one of the early days of doing Python programming, we needed Anaconda. Anaconda is only to build, what is that? So you can actually download Anaconda. You just type Anaconda Python download. So if you go to this, Anaconda is actually a suite of applications. It's not just one software. There are many softwares that come under Anaconda. So Anaconda will give you, there's got actually two IDEs inside Anaconda. So why isn't it not loading? Seems a bit slow, isn't it? So the Anaconda, in short, they call it Conda. So you can actually install Anaconda and also do programming with Python. And inside Anaconda, there is a software called Jupyter Notebook. I used to have Jupyter Notebook, but it's got a lot of stuff that I don't use. So I rather use download what I need rather than downloading the entire Anaconda, and then you have to launch Jupyter Notebook one by one, launch Jupyter Notebook or launch the IDE, the separate IDE and stuff like that if you wanted to do development. So this was the old way of actually doing Anaconda, and it's still very popular. It's not old, it's not bad. It's just that it depends on what you are very comfortable with. Then there are the newer ones. This is called PyCharm. PyCharm is another integrated development environment by a company called JetBrains. Okay, JetBrains is the one that built Android Studio, IntelliJ, and they also have PyCharm as a product. So you have to install the Python installer, the Python program, install PyCharm, and then you'll be able to create Python programs. This is highly recommended for Python developers. That means if you're a hardcore Python developer, I would suggest use PyCharm because it's got all the beautiful extensions for you to extend to write Python projects. It does a lot of work for Python programmers to generate very well written code. Okay, I can do the same thing with Visual Studio Code by installing the extension packs for Python. So I hope you understand how they differ now. So with Visual Studio Code, I can install the extension packs for Python and achieve the same functionality that's available in PyCharm. All right. Then for those who develop in purely Java, Kotlin, and Python, should use IntelliJ, which is also made by the same company that made PyCharm. Again, you can download Python installer, Java installer, Kotlin installer, and all of that inside one environment. So it depends what sort of programming you want to do and how you want to find the best tool. So, and these tools, right, keep changing because when I first started, Notepad was our IDE. We had to copy and paste every little thing ourselves. But Notepad is still there. So if you still want to use Notepad, you can. But the thing is, it's a bit difficult, right? It doesn't have these sort of nice interfaces for you to see your files and then to see your code. And then you got a nice button here. You can click and then run Python file. You got the terminal that opens up the terminal. All these things is provided by what we call an integrated development environment. All right. So this is why we gravitate towards these IDEs, because they've got loads of things for us pre-built. Okay. So this is what we call as an integrated development environment. So I can look at playing it, debugging it. I can even look at the changes that I have done, what code, which line of code which I changed, and what is new, what is old. I can search the entire data set for information, and then I can replace it with whatever, and then it keeps track of all my changes. I can publish it to my GitHub. I can do testing, So this is why we use the environment editor. So if you can't see what I'm doing, I'll just blow up the font a little bit. So you can see how easy it is for me to actually manage my software. So it's telling me what are the lines that changed and all of that. So this is what we mean by development environment. Because when we are building software, there is a life to that software. It's living because it's constantly changing. And if it's distributed, meaning there are many people who are contributing to it, it gets even more complex to manage. That's why we have GitHub. And in GitHub, like GitHub is where you have been downloading your software. So if you go to GitHub, it actually, let's say if you take a particular file, let's say we are looking at lesson 14, you can see that it starts to track 1 hour ago, last commit. So it keeps track of who actually committed. You can actually look at the history, how often has been committed. Then you can roll back. The last commit was the 2nd of November. So I can actually go back to that commit, So this is what distributed programming is all about. And it also is looking at how much coding that you've completed, and all that stuff is actually happening automatically for you, right? So you can see each package was uploaded at a different time. So all of this becomes very, very relevant when we, so if I go to my account, you can actually see how active I have become. I have become very active since September to November, thanks to this class, right? That means I've been using a lot of GitHub to publish my work. And so this is also something how we can actually see how active someone is in their development experience, right? So all of this is just tracked automatically. So yeah, so this account is about 4 years old, so I can actually roll back and see how I actually started to use a lot of this services and so on and so forth. So just to give you an idea of how what the kind of software, where is the file? So I hope installation, okay, so I hope that you understand now what are the Python development tools that you can actually use for this, all right? So this is a good slide to keep as a reference. Of course, I always have to qualify myself and say last updated today, because this is completely dynamic. It keeps changing with time. I better put December, then it'll look like okay. So I hope that's an introduction to Python. No, it's a very relevant question. You're all probably thinking about, I never thought about this, but I now, since you asked that question, I thought about it, and it's good for you to understand the depth and breadth of what you're actually getting into and how you want to position yourself. So so yeah, so that's so this is a good reference for you to use. So the class began with this in mind, because to make it easy for you to get started, but eventually I would move to this part because it's flexible and free. Again, Anaconda is free. IDE is there is a community and enterprise version. IntelliJ, again, community and enterprise version. So this one now gets to be, so I would put there community and enterprise. This is open source. This is, I wouldn't say it's open source. This is hosted for free. But the question is, how long will it be free? And all that is entirely up to it's Google's option. All right. Community means there is a free component, and enterprise means there is a paid component to it. Okay, so let's look at the code for today. So I have installed, so this is a pretty nice module called PyGame. It is it is developed by Python's community to handle multimedia effects. All right, and there are a lot of PyGame tools out there. Okay, a lot of Python PyGame. PyGame is a huge organization by itself. Okay, and they give you a lot of tools to how to manipulate images. All right, and then they have some simple games that you can try. Okay, so the learning process is just immense in this space, but they always begin with a tutorial. Okay, with a simple tutorial, and you can actually just copy this code here, probably download a couple of images, and you can actually run it for yourself, and then you can read the instructions as to how it actually completes. And then they have actually made it simple enough to understand. They have a function. The function is called load image. It passes in some variables, makes some changes, and so on and so forth. So that's how you keep improving in your ability to program. So it's actually based on the same thing. And then this is the one that actually runs the entire program. It calls the init. Okay, you have to begin by calling the init, and then you would have to give it a screen to display. All right, the screen to display is what we are doing here. Okay, we are calling the display, we are giving it the size, because that's the size. This particular display that you're going to see now is 120 by 400. Okay, so this is what sets up the screen, and then we are specifying an image to load into that screen. So the image is actually track number 6. So if you open track number 6, it's just an image like this. So this is the idea. You can actually create a racetrack of your own. You can just draw a racetrack, right? And you can then use that as your track and drive your car on top of it. So this is how this example is actually written. All right. So this is how we get to write the code. So this is the track, okay, and then this is the car. So you can see that car is now stored as a variable, and Tesla PLG is actually that car that you see, and I think this is Elon Musk, if I'm not mistaken. Okay, so this is a parody. of this whole self-driving car and whatever. So you can see that it's this simple. First you create the window. First you initialize, sorry, then you create the window, then you pull in the file to display as an image, and then you overlay another image on top of this, and you can see that they are different variables. So when I do car, I can actually move the location of the car given coordinates. So I can transform the car by giving the points and putting it into the transform scale. That means I'm taking the original car and transforming it and creating a new car. So you can see how I can now start manipulating the images that's loaded into the window. So this is basically what PyGame does. It allows you to manipulate the car. And then all the rest is just moving it left, right, up, down, and then we do a transform, rotate, transform, rotate, transform, rotate to actually then, and then we keep displaying the display. We keep updating it because you can see that this is going in a loop. Okay, drive is true, is going in a loop, and when I hit this quit button, which is right here, all right, then it stops, it comes out of the PyGame to quit, all right, and then it puts drive as false, and then it exits the loop, all right. So you can see that there is a clock ticker. The clock ticker is the one that makes it tick once every 60 seconds. So it's going to go this is 60, so let's see how fast it is. So it's going 60 times per second. So it's going 1 second at a time. So if you want to slow it down, we can just add another 0, and so it goes faster. So now it goes a lot slower. So I guess we are telling it to tick how many times. So we want it to tick 60 times. So therefore, it kind of makes the clock wait for a certain number of clicks before it continues on. So this is how basically we control the speed of the car by controlling this. So some of you can actually put this into a variable and allow the user to accelerate and decelerate the car as well using this clock tick, right? Now, what is this here? This cam X and cam Y is actually the camera that is sitting on the car. That means you will see that there is a green color dot. That green color dot is the cam X and cam Y, all right? So the cam is a preset offset. Okay, so now just want to let you know how we actually calculate the distance. All right, this right here is actually 0, 0. Okay, and this is let's say if it's 1200, then this is 1200, 0, and if it's 1200 and 640, so this is 640. So it is the opposite of a xy. So x would be here 0, and then here grow, right? So the x is the same. It's only that the y is going down this way. Okay, the y is getting larger as it goes this way. So it starts off here, and x goes this way and y goes this way. So that's the only difference from an actual coordinate system. So when you put all these numbers together, you're actually giving it a position. So when you say car X, that means on the X, 155 pixels this way, and car Y is 300 pixels this way. So that's how this is the X and this is the Y. So we are placing the car in a specific start position, and then the focal distance, that means how far ahead do I want to see? I want to see 25 pixels in front. And so that's how, that's when it will start to make a decision whether do I turn left, right, or whatever, followed by the camera offset. It starts off with a 0. So we start off with a 0, and then the initial direction is up, because you can see the image starts off with the upward motion first. Okay, and then drive is set to true. We set the clock ticker, and then we can start our driving. All right, we start driving the car. And then this is a for loop, because I'm constantly trying to get the event. Okay, each time this completes, I get the event. If the event is quit, then I exit. Otherwise, I do the clock ticking. That means I wait for 60 seconds. No, it waits for a certain number of time and then continues on. So all of this is just specifying what is going to be the camera location, what is the up pixel, down pixel, right pixel, and then prints the pixel down here. Okay, and then based on the pixel value, based on the direction as well, it will decide what is the up pixel, what is the right pixel. You can see if it's 255, then it keeps going up. If it's right is white, then it turns right. If the right is not sorry, if the direction is right and there is no more white on the right hand side, it goes down. So like that, we cover all the different possibilities of the car in order for it to travel through this space like this. Okay, so you would just need to, there's only a couple of options. I mean, there's only a few. Here it turns right, here it turns right, here it turns right, here it turns left, here it turns left, here it turns right, right, left, left, right, right, left, left. So it's either turning right or turning left. So there's only like there's only like 4 directions: right, left, up, and down. Okay, so it always checks. If I'm turning right, then I keep going until I hit there's no more white, and if there's white on the right, then I turn right. So it's basically wherever I see the white space where the 255 exists. So if you follow the coding here, it's doing exactly that. All right, so when the up pixel is no longer white, then I turn right. If it's right, so you can see that it will, once it this is when it's going up. Then when it's going right, if the down pixel is white, then it turns down. So you can see the direction is turned down. Then here, if it's going down and the right pixel is white, then I turn right. So if it's going down, turning right, going up, turning right. So basically, it's just like it's just taking a right turn all the time, you know. So and then we complete it. So basically, this is the gist of how you write the code for a self-driving car, right? So this part here, although it's very simple, but actually it is the foundation of how we decide for a car to turn right and left. Okay, so you can actually begin by trying to go forward and then taking going forward and then stopping, and then turning right and stopping. You know, there are few I would say trials that you can do before you get to a bit more complex, and then finally the more complex solution. All right, so this is how basically we train the model train the car to become more intelligent and more capable of achieving certain amount of self-driving capability.